Good morning. Now I will explain the solution for past year question 2024-2025. So let's see the first question. State a difference between electron current and hole current. So the answer is when voltage is applied across the semiconductor, free electrons are easily attracted towards the positive end, but holes will move in opposite direction to the motion of valence electrons. Next question is, with reference to figure 1, explain the mechanism by which an extrinsic semiconductor is formed. So the answer is the process of extrinsic semiconductor is called doping. The type of doping of figure 1 is n-type because it possesses majority electrons. Each pentavalent atom forms a covalent bond with 4 adjacent silicon atoms. Leave an extra electron becomes free electrons. Electrons are majority carrier and holes are minority carrier. And the third question, identify the function of each component in figure 2 and write your answer in the table. So the function of transformer is scale down AC voltage, then bridge circuit is convert the AC input voltage to pulsating DC voltage. Capacitor is produce a relatively smooth DC voltage. Zener diode is maintains a constant DC voltage for variation in the input line voltage or in the load. Let's see part B. For question 1, we need to determine the operating point of diode IDQ and VDQ using load line analysis. So we need to use Thevenin to solve this question. Change the diode position to RTH and find the RTH, it will be 650 ohm. Then find the VTH, VTH is 1.5 voltage. So we need to use this equation, then sub the VD equals to 0 and ID is equals to 0, and we will get the ID is equals to 2.308 milliampere and VD is 1.5 voltage. We draw the graph and we will get the answer. It is IDQ will be 1.1 milliampere and VDQ will be 0.74 voltage. Then B, calculate the resistance of the diode. So we use VDQ equals to IDQ multiply with RDQ, then we will get the RDQ is equals to 672.73 volt ohm. If the input voltage is increased by 50%, how will be the IDQ and VDQ? So we use the original voltage times to 1.5, and then we will get the VTH is equals to 2.25 voltage. And then we substitute the VD is equal to 0 and ID is equal to 0. So the new ID will be 3.462 milliampere and VD will be 2.25 voltage. So we will get the IDQ and VDQ is increased. Then question 2. First of all, we need to transform the primary RMS to get the secondary RMS. Then the secondary RMS will be 16 volt. Then we need to use the secondary RMS to find the V peak. So the V peak will be 11.314 voltage. Then the V naught is equals to the V peak here minus 0.7. So the answer is 10.614 voltage. And the V naught RMS will get 7.515 volt. B, determine the average output voltage across the load resistor. So we use 0.637 times 2 V peak. So the answer will be 6.761 volt. Then we need to find the peak inverse voltage PIV, which use V peak at V naught, and then we will get 21.928 volt. Third question, find the range of RL for Zener diode. So first of all, we need to find the IR by using KVL. So the IR will be 35 milliampere. Then to calculate the minimum IL, we use 35 milliampere minus 30 milliampere, and then the answer will be 5 milliampere. Then to find the minimum RL value, we need to use the Vz over 5 milliampere. So we will get 1.6 kilo ohm. If you want to calculate the maximum of IL and RL, so we need to change the current of Z is equals to 0 ampere. So the IL max is equals to 35 milliampere and the RL max will be 228.571 ohm. So the range of RL is 228.57 ohm to 1.6 kilo ohm. To calculate the maximum power by the Zener diode, so we need to use the maximum current of Zener diode and multiply with the voltage. So we will get 0.24 watt. So that's all. Thank you.